Hey, this is Leach with Simpson Math, and in this video, we're going to be talking about how to use the normal distribution. I'll be specifically showing off Desmos to answer some specific questions. This is targeted toward my contemporary students because their table is stupid, and so let's work some of these problems together. My current class, it is the questions 13 through 16 that this video covers, unless they change. So this is find the percent of area under a normal curve between the mean of the given number of a standard deviation from the mean. Note that the positive indicates above the mean while negative indicates below the mean. I'm going to put up a picture to kind of start drawing a little bit. So if I have a normal distribution like so, recall that if I'm looking at z-scores, this would be a mean, this is z-score of 0, 1, 2, 3, -1, -2, -3, because this distance right here is 1 standard deviation. So if I'm at 0 and I jump that distance of 1, then I would be at a value of 1. So these are my z-scores here. The question on the screen says it wants to know the area between the mean, which here's my mean at 0, and a standard deviation of 0.9. So let me clarify that. So if I have 0, and then right about here would be 0.9, I want to find the area between those values. So this area here. Now, the table that the book gives you will answer this very specific question very easily. But this table is stupid in any other applications. Like, I really don't like this table. It's just bad educationally. I could probably talk for an hour about why I hate this so much. So we're just not going to use it. We're going to use technology. So from our empirical rule, we know that if I went from 1 below to 1 above, that would be 68%. We're at almost half of that, so this should be almost 34%, but it's a wee bit less because that little section isn't covered. So I should know that it should be a little bit less than 34, just from my knowledge, just as a rough estimate. A little bit less than 34%. But let's just use Desmos. So I'm going to come over to Desmos, click the plus to add an item. We're going to pick inference, pick the probability distribution, and pick normal. I'm going to leave it at 0, mean of 0, standard deviation of 1. I'm going to go ahead and type 0 and 1. If I type it in, it will go ahead and plop it in as 0 and 1. I'm sticking with 0 and 1 because we don't have any values in context. We're just using z-scores. I know I'm using z-scores because it says in the given number of standard deviations from the mean. So since it's giving me a positive 0.9, that is 1 standard deviation above the mean. So I'm going to, and therefore I'm using z-scores, mean of 0, standard deviation 1. I'm going to toggle open our cumulative probability. We are looking for an inner area between a mean of 0 and 0.9. What I do, I get 0.316 as a percent though, because it does want it to be written as a percent. It would be 31.6 because I'm going to move this decimal place 2 places to the right. I can get 31.6%. Again, if I need more decimal places for some reason, let's say it doesn't want to round to the 10th but the 100th, I can press this output. It actually is a button. If I tap or click on this output, I can get a lot more decimal places. And in fact, if I click on this export button, it'll export it out to its own row. So I could do some math with it. Like if I wanted to go ahead and do it times 100, I could, but I'd rather you just move the decimal place than times it by 100. So that's where we get 31.6. I'm going to go ahead and press similar question until I get a negative. Here we go. I got a negative 1.2. So let me adjust this question. So I'm going to delete my inputs. And when I do, it kind of defaults just to -1 to 1. You can see how they're kind of a little bit gray. But I want from -1.2 and going to 0. So notice this time I left my mean to be the second number instead of the first because I want to input this in low to high. It will work if you do 0 to -1.2. Desmos will just flip the inequalities because they're trying to be helpful, which I love, is great. But I'm going to try to keep us be consistent. We like the less thans in math typically. So -1.2 to 0. That's where you get the 38.5. All right, let's do 14. So this says find the percent of area under a normal curve between the mean, and this time it says a negative 1.1 standard deviations from the mean. So this is basically the question we just did. Instead of it being just a random number here, this one is a below. So this is from negative 1.1 or just 1.1 below. So it is a negative 1.1 up to 0. That's where we get the 36.4. Let me press similar question, see if we get, so they're all just kind of giving me similar numbers. So here's a negative 1.11, so negative 1.11, and we get that slightly different number. So again, this is from my mean of 0, sorry, from my negative 1.11 up to that 0 into that shaded region. All right, now this one's a little bit more interesting. This is why these tables aren't very helpful for starting to get something like this. I want to find the area between a negative 1.6 and a negative 0.7. So I'm going to delete out what's here. And I want to get from a negative 1.1, negative 1.6 to negative 0.7. They're giving me them to be in order, so negative 1.6 is furthest to the left, and a negative 0.7 is the next one. And it's this region way over here. And I get 0.187 or 18.7%. It does one to the nearest integer. So they're using integer to mean as a percent symbol. So then that would be rounding to the nearest hundredth here, or the nearest percent is what I would prefer that they said, to the nearest percent, because these aren't integers, but my answer is a percent, the nearest percent. So we get, that should round to 19%. So yeah. I'm gonna do a similar question, see, is it gonna span? No, these, oh, that one does. Those are all positive. Do we have a negative to positive? All right, let me do this one. So this is from a 0.5 to 1.2, 0.5 to 1.2, and there we have it. Notice if it does, it was doing something weird. Oh yeah, if I just had a negative or something, it was saying a little warning saying, hey, that's not a valid number, put in a valid number. Yeah, all right. Last one. Last two, did I skip 15? Nope, this one's our last one. Okay. So on 16 here, this one is then the inverse. So here I want to find the this is the 20%, find the z-score that best satisfies the condition. So in this case, my answer is a z-score. So I'm going to go ahead and switch from, I'm computing no longer the area, but I'm computing the bounds. So this is the 20% of the total area is to the right of z. So I'm going to the right of a certain value. I'm going to find the upper 20%. So I'm going to change this to 0.2. So the upper 20% is up here. I'm going to do, I get this 0.2. And that would be a z-score of 0.842. I know it's a z-score because my mean is 0, standard deviation 1. So that's how I know that's going to be z. To the nearest hundredth would be 0.84. Let's go to a similar question. It wants that 33% is to the right. So I could change this to 0.33. So that's the shaded area to the right. That would give me my 0.44. If I want more decimal places, I could click this and open this up. It is being pretty accurate out to the third or fourth decimal place. It's just to the third decimal place with this 0.44 because it's really 0.440. I think this will give me a less than at some point. Here we go. So this one is a 36% of the total area to the left of z. So here, if I went to the left of z, I'm going to switch this to a left, and I'm going to have a lower 36% is to the left of z. And now notice my input here is a negative because I'm on the left side of the mean. So I'm below this. I'm below the mean now. So it's 0.358, negative 0.358, or rounding negative 0.36. Do be careful with the rounding is 1 to the nearest hundredth. All right. So that's those are those 4 questions. Playing with again, I would not even open those tables. Honestly, they're confusing. They hurt my head because they're not how you traditionally see tables. If you Google normal tables, they are not these. These are stupid. So just use Desmos, make your life easier, and I'll see you in the next video. Bye.